Hello, everyone. My name is Dan Qualiana, Head of Developer Relations at Zebra Technologies, and I'd like to welcome you to our July DevTalk webinar. This month, we're joined by Ugo Mastracchio. He is a Sales Engineering Manager covering Southern Europe, and he's going to be diving into F# and how functional programming languages can augment what you're trying to do building enterprise applications. Before we start off, though, I did want to remind everyone that you can find the slides and link to the GitHub repository at the Zebra developer portal at developer.zebra.com. And if you click on events, you'll be able to see information on this dev talk and all of the others that we have done. We also are recording this session and we'll be posting it on Zebra's YouTube channel. We have a playlist there covering all Zebra Dev Talks, so you can follow up and kind of rewatch any sections that you may want to revisit. We will have all this information posted later today for the slides and probably in a few days for the video. So without further ado, I'd like to turn it over to Ugo. But I guess one last thing before I do that, if you do have any questions, please ask them type them up in the question window of the webinar. And then I will be reviewing those. And once Ugo finishes the initial presentation section before he dives into the code, we'll address some of those questions. And then at the end, we'll go through the rest of them. So Ugo, can you please introduce yourself and kick things off here?
Sure, Dan. Can you hear me okay?
Yes, I can.
Very good, very good. So I guess Dan has already introduced myself. I work out of Milan here in Italy, and it's actually a fantastic day, a very sunny day, mid-afternoon in Italy at the moment. I've been working for Zebra for a long time, 20 years actually, and I've been really working closely with the Zebra partner community here. And as a long time functional programmer, I've recently been developing some demo application in F# to demonstrate to the reseller community and to our customers some specific features of our mobile computers and printers and link them to specific use cases. So I guess the idea behind this webinar is to make you guys aware of a substantially different way of programming that is functional programming that today becomes a viable option also for mobile applications or cloud printing applications development. And because it's all .NET based, there is total interoperability between languages like C# and F#. And so one can start effectively developing .NET standard libraries in F# and use them in a C# program or vice versa. What we will do today, we will look at some of the advantages of F#, but also the practicalities of developing for Zebra devices in F#. And of course, you will find links in the slides to resources available on the web to go deeper on F# if you want to do so. Let's go to the agenda. So I will introduce F# from the object-oriented programmer perspective, my assumption being most of you guys have a strong object-oriented background, not necessarily a functional programming background. I will then talk about the state-of-the-art of F# tooling today. I will then move on to talk about F# Xamarin support and integration with Zebra EMDK. I will also do a little bit of a code walkthrough on a couple of applications that are in my GitHub repository and that are available for you guys to clone, download on your laptop, and play with your IDE of choice. I will also finally talk about how F# can also be used to develop Weblink endpoints. And for those who do not know what a Weblink endpoint is, I think it would be actually an interesting discovery connected with some advanced capabilities of our printers. Okay, so what is F#? F# is a functional first .NET programming language with full object-oriented support. This is probably the most common definition that is associated with the language. So I guess the next thing would be to define what a functional programming language is. And in a functional language, basically a program is just a set of functions, and you compose functions to build bigger function and ultimately the program. It's a little bit like the pipe approach in Unix shell, or the process of connecting Lego blocks together. It is actually quite common for functions in a functional language to take other function as parameter or return a function. You can also partially apply a function. So really the distinction between function and values is somewhat blurred in functional languages. I said F# is a functional first language because it encourages the programmer to adopt a functional approach to programming, but it's also a fully fledged object-oriented language. So you can define your classes, your methods, properties, interfaces, and the like, very much like you do in Java and C#. You can actually decide to use F# as an object-oriented programming language and leverage inheritance encapsulation, and this can be actually a sensible initial approach to the language. F# was originally created a few years ago now by a Microsoft research team led by Don Syme at Cambridge, and it's maintained and further developed today by the F# Software Foundation. It's fully open source. Certainly the great F# community we have today is one of the reasons for me to love the language. Functional programming has a long history in computer science, and chances are you guys may have bumped into programming languages like Scheme, ML, at some point, maybe as a university student. One can actually say functional programming even predates computers. In the 30s of last century, a few people, logicians, mathematicians of kind, came up with alternative formalization proposal of the concept of computability, and really the root of functional programming can be traced back all the way to lambda calculus, an alternative way to formalize computation that you can actually compare to Turing machine. Let's now fast forward to the present day, and I've put in the slide a few examples of how functional programming is growing in relevance. The examples of F# adoption in the real world I took from the F# Product Manager presentation at Build 2018, the Microsoft event for application partners that was recently held. For the sake of time, I'm not going through each of the examples in details, but I think what the guys at Jet are doing with F# is worth mentioning. Jet.com is an e-commerce company acquired by Walmart in 2016, known for its innovative pricing engine that finds an optimal cart and the most savings for the customer in real time, comparing hundreds of e-commerce prices and taking into account not only the item price, but also the shipment costs, and analyzing all of the possible combinations, coming up with the optimal solution. The software behind all this is developed in F#, and the article that I reference goes in some level of architectural details. even if you've never been exposed to functional languages, it's likely you may have indirectly heard of functional constructs as a Java or C# programmer, since another notable trend lately has been the adoption of functional constructs by the mainstream programming languages. The ones that I list in the slide originated in the functional programming world and then made their way into mainstream languages. Okay, so let's talk about some distinctive features of F#. What I do in this slide is compare code written in F#, and you have it on the left-hand side of the screen, and C# code on the right-hand side. It is effectively here the same function, sum of squares, that is coded in the two languages. It calculates the sum of the squares of the first n integers, but what you notice is, and this is fairly typical, F# is less lines of code than C#. And I would definitely say is clearer code. It is mainly because in an F# program, you don't have all the clutter connected with semicolons, curly braces. But it's not only that. You may have noticed you don't specify types for variables in F#, and white space replaces parentheses in many instances. In the F# code on the left-hand side, you see the let operator being repeated multiple times, and that is what is used in F# to define functions or values. And we will come back to the let bindings in a couple of slides. The other thing you notice is the usage of the pipe forward operator. It's actually one of the most important operators in F#, and it really helps improve the readability of the code. The idea is that the value on the left-hand side of the operator is piped into the function on the right-hand side of the operator. So sum of squares is actually defined as the list of integers from 1 to n piped into the map function that takes square as a parameter and the list 1 to n as the second parameter. The result of this computation is then piped into some function. Map function is a polymorphic function. It takes a list of type A and apply the function is got as first parameter to each element of the list. And it builds a list out of the return values. The sum function is a built-in function that takes a list of integers as a parameter and simply returns the sum of the elements. The other thing that is worth noticing here is that in the F# code, you really don't tell the system how the result should be calculated. And this is very typical of functional languages. They are also called declarative languages. For and while statements, the type of things that you have in the C# code, don't really have a place in F#. Well, I have to take it back a little bit. For, you have a for statement in F#, but it's got a totally different meaning than C#. Let's now look at class definition in F#. Same class here, customer name, defined in F# and C#. Again, less lines of code in F#, mainly as a result of the fact that the class constructor is implicitly defined. Parameters automatically become immutable private fields that store original values that were passed in. Both properties and method use the member keyword in F#. We'll see a few more classes definition in the F# samples that we'll go through later in the webinar. I believe we are all familiar with the concept of immutability. And in object-oriented programming, it refers to an object whose state cannot be modified after it is created. Well, immutable values and types are the default in F#. The idea in F# is that you transform data, you don't change them. And why immutability is good? Immutability is good because it makes the code predictable. If that data is immutable, there can be no side effects. If there are no side effects, it is much easier to reason about the correctness of the code. The good thing about F# though, and this is where it differs from other functional languages, is that it is not dogmatic about immutability. It does support mutable data with the mutable keyword, as you can see in the example. So in the example, let v equals exp, v is just a name for the value on the right-hand side. This is called let binding. In let mutable w equals expression, w represents a register in memory where values can be copied into. So mutability is supported. But turning on mutability is an explicit decision by the programmer. And mutability is needed when dealing with .NET libraries. We will also see how dealing with mutable data is required when working with Android user interfaces classes. But what F# does, it encourages to minimize such mutable state. You can generally still design your core business logic to use immutable data with all the corresponding benefits, and then confine mutable data to small areas of your code. So I would really say let bindings are the basic building block of F# programs. The other thing that I would say is, don't know about you, but to me, the choice of the equal operator for variable assignment in many programming languages has always been a mystery. I guess we are so used to it that we think that a statement like w equals w plus 1 is perfectly normal. But it only makes sense because the meaning of w on the left-hand side of the operator is completely different from the meaning of w occurrence on the right-hand side. So my point is, why use equal then? And in F# you have the left arrow symbol as variable assignment operator for mutable variables that to me is a much more natural choice, indicative of what variable assignment really does. And now we come to another significant advantage of the language. To many F# programmers, not having to deal with null references is the single most important advantage of F#. Null reference exception is, I'm sure you will agree, one of the most dreaded and unfortunately not uncommon situations. In F# you have the concept of a type that supports no value. That is the option type. And null is replaced by none. The language is automatically forcing you to deal with the none case. Not dealing with none is a compile time error rather than a runtime error, which makes all the difference, of course. You actually find out before you even click the build button if you've not dealt with none. There is a very nice talk from Tony O'Hare. This is the English researcher who originally introduced null in the 60s, I believe, in algo programming language, and that reflects over how introducing null was a bad idea and tries to estimate the cost associated with that. In F#, we mentioned we have type inference, and that eliminates the need for the programmer to specify types of functions or values. The compiler will automatically do the magic and get them for you. That's not the only unique thing about the F# type system. F# has a rich type system that allows developers to accurately represent the model of a subject matter expert. Instead of relying on controls in the code, everything is defined in the type. So these are rich type, yet easy to read, even for somebody who's not a programmer. What I'm actually saying is that F# is an ideal platform for domain-driven design. So those who are interested to know more about the subject, I highly recommend a talk from Scott Lashing, and whose link is in the slide. I have to mention concurrent programming, as it is becoming more and more relevant in mobile application development. And it's actually very easy to do concurrent programming with F#. This is where the mutability choice pays the dividends. Because of immutability, your program is inherently thread safe. F# has got something called async workflows. And these allow programmers to convert single-threaded code into multi-threaded code with minimal code changes, with no need for control inversion. What you tend to have these days is this spaghetti code, I would call them, where you have callbacks everywhere, and you need to have external knowledge to be able to interpret what is really going on in your program. F# also have an alternative approach to concurrency, which is based on the actor model implementation, which is built in F#. I've actually used mailbox processors myself extensively in my cloud printing demo app, so we will look at that later in the presentation. So I guess enough for the theory. Let's talk about tooling now. F# supports all .NET implementations today. F# runs on .NET Framework, Mono, Xamarin, and .NET Core. F# compiler is actually part of .NET Core. F# is also supported in all Microsoft integrated development environments, including Visual Studio 2017, Visual Studio for Mac, and Visual Studio Code. All the editor tooling, the IntelliSense, and the debugging functionalities you expect are all available for F# programs in Visual Studio. Visual F# is updated as part of the Visual Studio update process. But for the impatient, it is also possible to configure extension and updates within Visual Studio to point to the Visual F# tools nightly feed. When a new nightly feed is published, when a new nightly VSIX is published, you'll get a notification in Visual Studio. An F# REPL is also available in Visual Studio, and again, there's a lot of work the F# community does to make tools available to the F# programmers. I'm listing just a few here. Certainly Fable and SafeStack are probably worth mentioning among the others, as they are getting a lot of traction in the F# community today. So let's talk briefly about Xamarin now. I'm sure you know everything about Xamarin based on Mono. It basically allows you to develop native application for iOS, Android, and UWP. Zebra has offered the Xamarin EMDK and the Xamarin LinkOS SDK for a few years now. And the API set that is offered is virtually same as the respective Java SDK. Xamarin has become pretty popular, certainly here in Europe, with the Zebra application partner community. And I've personally been involved in projects with several key customers where Xamarin was selected as the development platform as this customer migrated to Android Zebra devices. Value proposition is you can leverage your .NET development resources to develop native Android applications, leverage the vast .NET library, and reuse .NET code. It's also used by our partner community to build printing applications for Android and iOS devices when it comes to target Zebra mobile printers. While the majority of our Xamarin partners still develop in Xamarin Android, Xamarin Forms is certainly growing in popularity, particularly when the application is targeting multiple OS platforms. The entire code is reused with Xamarin Forms, and I will present a couple of Xamarin Forms demo applications today. And now for the great news. All you do in Xamarin with C#, you can do with F#. Solution templates are available in Visual Studio 2017 for Xamarin Android F#, and Xamarin Forms F# template is available in Visual Studio for Mac. I know for a fact that the Visual Studio team is working to add Xamarin Forms F# template in Visual Studio for Windows as well. I guess the even greater news is Zebra Xamarin EMDK works nicely on F#. You can actually build either Xamarin Android or Xamarin Forms application for Zebra devices, leveraging Zebra MX capabilities and integrating barcode reading through DataWedge API. Also, debugging of F# projects on Zebra devices is fully supported on Visual Studio. Actually, any Visual Studio. What I would say though, Visual Studio 2017 is highly recommended if you use Zebra EMDK with an F# project. My experience is Profile Manager works perfectly on 2017, not so much on 15. So if you've not upgraded yet and you want to try F#, it's the right time to upgrade to Visual Studio 2017. That's something you need to be aware about our EMDK library. In previous versions of EMDK for Xamarin, the EMDK API were distributed to the projects through a Xamarin component. In late 2017, Microsoft announced that it would be discontinuing support for Xamarin components and that all providers would be required to use NuGet packages. Zebra will officially support NuGet packages. In the meantime, the instructions in the link I'm providing cover the MDK for Xamarin NuGet package installation. Basically, in order to reference the MDK library into your Android project, you need to install the MDK NuGet package, getting NuGet applet to point to a local file. All the information is in the link. I also want to mention an announcement that was made at the beginning of the year that really is a testament to Xamarin commitment to F# support. The creator of F#, Don Sign, will spend the next 2 years with the Xamarin team to help make F# better for mobile application development. This is obviously a great news for the mobile F# community. Okay, so time to jump into the code now. What I have is a few F# applications in my GitHub repository here. And I want to do some code walkthrough with you. What I have is a Xamarin Android EMDK application, a couple of Xamarin Forms applications targeting Zebra devices, and a Weblink endpoint for our LinkOS printer developed in F#. Again, the source code is freely available to you. You can clone the apps on your laptop, open them in Visual Studio, ready to go. Git support is obviously available on Visual Studio, so it's really a matter of a couple of minutes. Okay, so at this point, let me switch to my Visual Studio here. Okay. So this is Visual Studio 2017 Community Edition running on my laptop. I believe this is the latest version, version 15.7.5. As you can see, Zebra Profile Manager is installed, and my Xamarin Android project is opened. So for those familiar with Xamarin development environment, it's really nothing special. This is a single activity Android application, and the main activity class is defined in the main activity.fs file. So this is the main activity class, but this is not the only class that is defined in the file. I've also subclassed broadcast receiver, is this bReceiver class. And the idea here is that I'm passing to the class the functions that I want to call when an intent is received, depending on the specific action. Whether a barcode is received or the intent is a response to a DataWedge API. So if I hover with the mouse over the class parameters, the type that the type inference engine has assigned to the parameter is revealed. In this case, I have specified a type for the parameter, but actually, if I remove the type definition, it's the type inference engine that will calculate the type of the parameter for me. So this bReceiver class is instantiated in the onCreate event of the class, of the main activity class, and it's assigned to a mutable private variable within the class. Show barcode toast, show active profile, these are activity methods that are passed to the broadcast receiver class. The broadcast receiver is then dynamically registered in the onResume activity event here. And it's associated to two different actions. So I have the application running on a TC20 device connected to my laptop. And the idea is when I scan a barcode, the toast will pop up and display the barcode data. If I go back to the onCreate event, what I do is subscribe to the check change event. And I pass what is called an anonymous function, also called lambda function, that sends a request to DataWedge to switch to the selected profile. It's this send switch profile intent function. I also subscribe to the button click event on line 240, 230. And every time the button is selected, I send a request for the active DataWedge profile name. The activity class in this application also implements the EMDK listener interface. This is the implementation of the interface. And if you hover with the mouse over the class name, you have confirmation that this class is inheriting from activity, but is also implementing EMDK listener interface. Zebra init method is called in the onCreate event of the class. To initialize our EMDK. And then Zebra set power profile method is called when the MX button is pressed. Let's have a quick look at how the application looks like. I have Visor running on my TC20. This is F# EMDK sample application. I click on active profile and the toast with the active profile name pops up on the screen. I change radio button. I've sent an intent to DataWedge requesting a DataWedge profile change. And now active profile is F# no illumination. Go back, active profile is changing. Scan a barcode, and barcode data are displayed on the screen. All pretty standard according to Zebra best practices. Relatively new code, yet it's still in the good old structure of an Android program. Concise code, yes, but really not so different from C#. Let's shift gear now and let's analyze a couple of Xamarin Forms applications you can find on the GitHub repository. And let me go back to my slides. For these two Xamarin Forms applications, I've used the functional user interface pattern that is the result of Don Syme work at Xamarin this year. You find the references in this slide. It's called Elmish for Xamarin Forms. Many of you, I'm sure, are familiar with the MVVM UI pattern, model view model UI pattern that is frequently used these days in Xamarin Forms, what we have here is a functional model view update user interface pattern, and now classes totally disappear from UI definition. The model is your immutable collection of data, and you transform your model based on messages triggered by UI events or external events like a DataWedge intent as a result of a scanner. What you basically do in your program now is define a model and then an update function and a view function. In the update function, you define how your model gets modified based on the message received. And the view function is the one that defines, depending on the model, the user interface via a domain-specific language. Let's look at the solution now. So the first thing you notice is the solution actually includes two projects. One is a .NET Standard 2.0 library that contains the platform independent code. And this is where the model, the update, and the view function are defined. The main file in this library is app.fs file, which are currently open. The model is defined as a record type. In this case, message type is a discriminated union type. And then you have the update function that, depending on the message, that take the message and the model as parameter, and depending on the message, transform the model into a new model. And then you have the view function that, as I said, takes the model as a parameter and defines the user interface and the messages connected to the different controls. So in this sample app, I'm using the Xamarin Forms messaging center mechanism to subscribe to events coming from the Android project, specifically connected with barcode scanning event and trigger notification. So if I now move to the second project, which is the Android project, what I have is the standard activity class definition. And as a method of the class, I have this send to app function that send data to the Xamarin Forms app with a message tag. The send to app method is partially applied in the DataWedge broadcast receiver instantiation in the onCreate event. So depending on the type of broadcast intent received from DataWedge, a different message tag is sent. This is the instantiation of the class, and this is the partial application of the function, meaning I'm just passing one parameter to the function. So effectively, this parameter is just a function of one parameter, and I pass it to the constructor of the class. For details of how the process works, and I'm specifically talking about the messaging center mechanism, you can refer to Bill Haycock's presentation in the 2017 North America App Forum. He built a very nice C# sample app in Xamarin Forms. So now let's just have a look at the application in action. So it's C# inventory. The label of the activity is F# inventory. And at startup, the application is reporting the scanner framework version, the DataWedge version installed on the device, and it's also actually registered for scanner status notification. So the scanner status is currently in waiting. If I press my trigger button, the core Windows Xamarin Forms application will receive a notification with a new scanner status. When I remove the finger from my trigger, the scanner status goes back to waiting. I now read the barcode. And again, the send to app application will send a new notification through the messaging center mechanism to the core application. There is a really cool feature connected with Elmish for Xamarin Forms. And what this feature does, it allows you to run your application inside your Zebra device. And whilst the application is running and you edit the code inside your core project, you can see those changes happen live inside your running application. This is something that I think is pretty unique. Let me see if I can demo it. So the current text color in the reset count button is evidently red. Let me go to my app.fs file. Let me go to the view model. Let me change this color to blue. Theory goes, I just save app.fs and the update should be immediately transferred to my application running on my TC20. And now the text in my button has gone blue. Really nice feature I found. So you can actually constantly modify your user interface without having to rebuild your application all the time. Okay. So let me move to the next application, and I believe we need to rush a bit as we don't have much time left. What this application is actually the F# version of the set clock application that Billy Haycock presented last year at the North America App Forum. Again, it leverages messaging center and dependency injection. Dependency injection is actually the mechanism whereby the form send a set clock command to the main activity. crossing the project border from one project to another. I will not go through the code, but I'm in the slide. I'm giving you the link to the original build code and to my code, so you can compare and contrast F# with C#. Again, what differs is the approach to user interface. I'm again using the Unmesh for Xamarin Forms user interface pattern, whereas build solution is based on standard XAML-based user interface for Xamarin Forms. Again, both solutions leverage messaging center and dependency service to exchange data between the Droid activity and the Xamarin form. Let's have really quick look to the application. Yes, F# EMDK, Xamarin Forms. So what you've got here is the iDeviceConfig interface, which is defined in the Xamarin Forms library. And then you got its implementation in the Droid project, specifically in the deviceconfig.droid.fs file. This class decoration here, it's done specifically in a different way than C#, so you may want to take notice of this. Okay, so we've arrived to the last application I want to present today, and that is a cloud-hosted Weblink endpoint. This has been implemented in F#, and it's a relatively bigger application compared to the previous ones. I've used extensively this application in my link-OS labs with the partners here, and it is actually available for you to play with on the cloud. Weblink is the Zebra WebSocket implementation on Zebra link-OS printers, and it is the technology behind AVSPO printers, Printed Profile Manager Enterprise, and other tools. What Zebra does, Zebra provides a Tomcat server and APIs to actually build a Weblink endpoint, and that is part of our link-OS SDK. But we also have application notes that describe how to build your Weblink endpoint with your specific library or framework. And this is actually what I've actually done here. Weblink is not just for printer management. It can also be leveraged to run printing applications in the cloud with all the advantages of cloud software deployment. The specific demo application that I have here it's actually designed to demonstrate how to leverage Zebra Weblink technology to support multiple use cases, like repricing in a retail store, label conversion, and self-serving shipping label printing in a parcel shop. I believe then I should stop here for the sake of time and maybe allow the guys to ask a few questions.
All right, thanks, Ugo. This has been a really helpful overview of F# and trying to understand how it fits in with some other existing Zebra tools, how people can leverage that. And I think this code, as you're going through usage of the mobile computers, of the printers and other things, it's really beneficial for people. So again, if you do have questions, please feel free. You can type those up in the question window. There were a few questions earlier, but you addressed them throughout the presentation. So right now we don't have any open questions. I think we can give people another minute. And just as a reminder for everyone, later today we'll have Ugo's slides as well as links to the GitHub repository posted to the Zebra developer portal at developer.zebra.com. We're going to have that up in the events page on the developer portal. So Hugo, it doesn't look like there's any questions popping up. I think, for some people, if they have a background with F#, they're going to find your sample code really helpful. And for those who don't, this was a great starting point. They're probably going to need to spend a little time digging in to learn more.
I think so, yeah. I really hope this has been useful, guys. And yes, let's keep in touch. And please post your questions to the email address that Dan is providing, and we'll try our best to address any questions that will come our way.
Yeah, so feel free to ask any of those questions on the developer portal. Particularly for this, for the post about this webinar, we're able to, you can post a response there and we can write back and try to help you out. So Hugo, I want to give a big thank you to you. This, as I said, was extremely helpful. I think it would be really nice for our developer community. I'm excited that we have this code out there, and we'll have this video and the presentation for people to learn more. So thank you.
Thank you, guys. Have a great evening. Bye.